activity of Scutellaria, AKT, PKB signaling. My main purpose was to find a way to inhibit glioma by using plant leaf extracts from the plant Scutellaria. Well, ladies and gentlemen, I would like to bring you into the introduction of the educational part of the talent. Apoptosis, which is cell self-suicide, is a method used by cells in order to help them better grow and develop and maintain homeostasis. But there's one problem. AKT, or also known as protein kinase E, has been a strong promoter of cancer through allowing cell survival and cancer cell growth and proliferation. So, how does it do this? Well, we start with the top of the line with the kinase called phosphatidylinositol 3 kinase that moves down to AKT eventually, and that then allows other proteins such as BAM, which is the BCL2 apoptic promoter, to allow cell survival. Now, again, the purpose of my experimentation was to find the best inhibitor of AKT using F98 cells using Scutellaria leaf extracts. I conducted prior research at Fort Valley State University trying to find the best way to multiply and conserve Scutellaria barbata using a Sensi technology and also using in vitro plant emulsification. I found out through research that Scutellaria barbata has been used in medicinal research and Chinese traditional medicine as an anti-inflammatory and used in modern medicine to inhibit breast cancer and lung cancer. The other species worked with was Scutellaria okomogi, which is a species that's actually indigenous here to Georgia, but it has no medicinal value. So that led me to my experimentation. Here you see are the actual F98 rat glioma brain tumor cells. This is day 1, this is day 4. In day 4, you see there is no space, and basically this shows you again that they are cancer cells. Cancer cells have no contact inhibition, meaning that even though when they touch, unlike normal cells, they continue to grow and multiply. I then carried out other processes such as counting the cells with a hemocytometer and treating the cells with their elite extracts. A Bradford assay was conducted to make sure that there was protein in each sample, and then later on, a sodium didactyl sulfate polyacrylamide gel electrophoresis was ran to better analyze the protein. I then conducted a gel analysis, as you see here, as well as a Western blot analysis. Now, what are you looking at? Well, basically, the darker the band, the more cancer activity. The lighter the band, the smaller the cancer activity. If we look at the phospho-AKT, which shows you how much AKT is activated in the cancer activity itself, you see the zero is completely flat. But moving to the higher concentration of Scutellaria okomogi, you clearly see it's fading. When all the gels and blots were analyzed, you see that Scutellaria okomogi in its higher concentrations virtually half of the cancer activity of the control, showing that it is a strong inhibitor of AKT and therefore leading to less cancer development. So my conclusion was that the plant that's actually here from Georgia, not the one from China, was the best inhibitor of the rat glioma brain tumor cells. The applications for this project may be used as a cancer therapy. After being tested on U87 cells, we can further count it as a cancer therapy. It also encourages more studies in traditional and herbal extraction medicinal studies. It calls also stronger methods for the conservation of Scutellaria okomogi because it's actually a threatened species as declared in 2006. I, of course, have to thank many people who helped me along the way of this project. Dr. Perry Julie at the Carmichael Cancer Institute, Dr. Joshi, who helped me at Fort Valley State University culture these plants, and my parents, Cora Bales Gibson and Alfred Gibson, who helped me morally and financially get to Detroit. I'd like to thank you all for listening to my presentation, and I want you to remember, when you think about cancer, Johnny Fales III has the answer.